Okay, I've got a quick little experiment I would like to show you, and in the interest of time I've videoed it instead of showing you in the lesson, so let's get going. So we're going to be looking at how the temperature of a wire affects its resistance, and that's going to be really important as we start to look at components that are ohmic or non-ohmic and why they might not have constant resistance. So here's my nice little circuit, nice and simple. I have a wire here that is connected to a battery, and then in the circuit I have an ammeter to measure the current in the wire and a voltmeter which is in parallel across the wire to measure the voltage across it. I'm going to show you quickly that on the circuit diagram, which should make it nice and clear. So there was our voltage source or our battery, the resistance wire, an ammeter to measure the current in the circuit, so that I know how fast the charges are moving around the circuit, and a voltmeter so that I know how much energy the charges are losing as they pass through the wire. So I connected it in parallel from both ends, from the start and the end of the wire, so I can see what the potential difference across the wire is, or how much energy each charge is losing as they pass through the wire. Okay, so I want to find out how temperature affects the resistance of a wire. So at first, when the wire is cold, I'm going to measure the voltage across the wire and the current in it, and you will calculate the resistance. And then I'm going to heat it up using a Bunsen burner, and we're going to take the same measurements again when it's hot, and you'll measure the resistance again, calculate the resistance again, and we will see what the relationship is and look for an explanation. Okay, so I've connected the circuit up, and the voltage across the wire is 0.28 volts, and the current in the wire is 1.26 amps. So, can you please calculate the resistance of this cold wire, and then I will get to heating it up and see how the current changes. The current before was 1.26 amps. Let's have a quick look down at my ammeter, and it has dropped all the way down to 1.19. So we've got a much lower current in this hot wire. So when the wire is hot, think about what is actually changing on the atom level within that wire. Current has significantly dropped away. Okay, so for all the all-important numbers, which will allow us to calculate the resistance and see the difference, I continued to heat it, a little bit safer when I wasn't holding a camera, and the current dropped all the way down to 1.10 amps, but the voltage stayed pretty constant at 0.28 volts. So the current has dropped away significantly, the voltage across the wire has stayed the same, so the rate at which the charges were moving through the wire has really dropped away there. But we need to back that up with some numbers. We need to calculate the resistance of both wires. So can you please use those numbers to calculate the resistance of the cold wire and the hot wire? Compare the two, and then can you come up with a reason? Can you think of a reason why there may have been a change in current from when the wire was cold to when the wire was hot?